Okay, guys, so I wanted to solve a problem related to conservation of energy that is very typical, a very typical problem when you solve conservation of energy problems. So let's say that you have a track, right? There's a track like this, let's say, and then there's a mass on the track. Okay. Now, so obviously the question is given to you in several different ways. So what we're going to do is, let's say we have to find this height h at which we should release this block so that it loses contact over here. Okay, so the condition is that find h. So find h so that the mass loses contact at point, let's call it A. Okay, so this is point A. Now we can and let's say that the radius of this track is r. Okay, so that's the radius of the track. Now this is obviously, this height is going to be 2 times r, right? So if you so let's say this height, right, this is 2 times r, right? So now the block starts at rest, so initially its velocity is 0, right? So we can apply conservation of energy and compare the energies and get an idea of what the velocity is, for example. So let's do that. So let's apply conservation of energy. We're again assuming that it's a frictionless surface. So this surface is frictionless. Okay. So total energy is going to be conserved. So that means that the total energy at the point where it starts, that's mgh. So that's your initial point, and then this is your final point in this case. So then you have at point A, it's half mv squared plus mg times the height. The height at A is 2 times r. So now we can we have an equation that obviously has h in it, but we don't know v, right? And now we can look at the situation at point A and look and see what Newton's second law gives us, right? So let's look at the free body diagram at A. So at point A, there are 2 forces acting on the mass, and there's a normal force, right? And then there is there's the weight of the object. So there are 2 forces, right? So okay, so the normal force and the weight. So now these 2 forces together play the role of centripetal force. These are the only 2 forces acting there towards the center, and therefore the sum of these 2 is going to be equal to mv squared over r. So let's call this equation 1. Okay, so at point A, we have situation is that n plus w is equal to mv squared over r. So the condition is that we have been given a condition that if the block loses contact, right, the mass loses contact. So that means if it loses contact, then what happens is that n is equal to 0. Okay. So when n is 0, we get, so remember that w is mg, right? So we get mg equals mv squared over r. So the mass cancels out, we get v squared equals rg. So what you can do now is you can plug, so let's call this equation 2. So what you can do is plug 2 in 1, right? So now remember, you can divide it by the mass in 1. You can add a step over here. The mass cancels out. So when you do that, when you plug 2 in 1, we get gh equals v. So we're going to plug that in. So rg over 2 plus 2gr. Okay. Now you can see that the g cancels out also, right? So G cancels out as well. So now we're just left with H and R, as you can see. So H, you can see, is R over 2 plus 2R. And so so we get 5 by 2R. So that's the height at which, if you release the block, it is going to lose contact at point A. Okay, so that was it. You can also look at, so in some questions, let's say you might be also given a situation where you have to, for example, figure out what is at this point. So I'm just going to give you a hint on that. You can just apply conservation of energy, and then the height at this point is going to be R instead of 2R. And then you can apply the difference over here obviously is that at this point the normal force is towards the center, so there's a difference. The normal force is over here, and then the weight is straight down, so that's the difference. So this is the weight, this is the normal force. The normal force is equal to mv squared over r, and weight is just going to be like it's like a tangential force. So but you can apply conservation of energy, and then typically in these type of situations they'll tell you, okay, the weight of the block is the normal force on the block is, let's say, twice its weight or something like that, and then you can apply conservation of energy a similar way, but remember the centripetal force is going to be different, and solve the situation. Okay.